Now let us discuss about the differences between electron, proton and neutron. If you observe, electrons are negative in nature. The nature of the electron is negative. The nature of the proton is positive. The nature of the neutron is neutral. So neutral in nature, neutron. And if you observe the charge for electrons, so electrons are negative charge. So what is the amount of the charge for electron is minus 1.602 into 10 to the power minus 19 coulombs, or if you say in ESUs, electrostatic units. ESU stands for electrostatic units. So the charge for electron is minus 4.8 into 10 to the power minus 10 electrostatic units. In the same way, the proton is also having the same charge, but in opposite. So the charge for proton is plus 1.602 into 10 to the power minus 19 coulombs, or plus 4.8 into 10 to the power minus 10 electrostatic units. And if you observe the charge for neutron, so neutrons are neutral in nature. That means no charge for neutron. So no charge. That means zero charge. Zero. The charge for neutron is zero. If you observe, the mass of electron is, if you say in grams, 9.1 into 10 to the power minus 28 grams. If you say it in kilograms, 9.1 into 10 to the power minus 31 kilograms. Or if you say in atomic mass units, AMU, 0.00055 atomic mass units. If you observe, the mass of proton is more than the mass of electron. If you observe here, 1.672 into 10 to the power minus 24 grams. If you say it in kilograms, 1.672 into 10 to the power minus 27 kilograms. Or if you say it in atomic mass units, 1.00672 atomic mass units. And if you observe the mass for neutrons, that is 1.676 into 10 to the power minus 24 grams. If you say it in kilograms, 1.676 into 10 to the power minus 27 kilograms. If you say it in atomic mass units, that is 1.00867 atomic mass units. If you observe the masses between proton and neutron, there is slight difference. Here 1.672, here 1.676. There is slight difference between the masses of the proton and neutron. Here also same thing, AMU also. Here 1.00672 AMU. Here 1.00867 AMU. This is a small difference in the mass of the proton and neutron. And another words, you can say the mass of the electron is 1 by 1837 part of hydrogen. So 1 by 1837 part of hydrogen. The mass of the electron is 1 by 1837 part of hydrogen. So in the hydrogen atom there is one proton and one electron. So the mass of the electron is 1 by 1837 part of hydrogen. And if you observe the specific charge, the specific charge is nothing but charge to mass ratio. Charge to mass ratio. So the ratio between charge and mass is nothing but specific charge. So if you calculate the charge of electron with the mass of the electron, the value will be 1.76 into 10 to the power 8 coulomb per gram. This is the specific charge value for electron. So this specific charge value is given by J.J. Thomson for electron. If you observe the proton specific charge, this specific charge is constant for electron, but the specific charge is not constant for proton because it depends on the gas atoms. So, but here not. The specific charge value for electron is constant. The specific charge value is not constant for proton. It depends on the gas. If you observe the specific charge for neutron, E by M value is 0. Why it becomes 0? Because the charge by mass. So E by M value. E by M value. So neutron is having mass, but there is no charge. So that is equal 0 by 1.676 into 10 to the power minus 24 gram is equal to 0. So the specific charge for neutron is 0. The charge for neutron is 0 and specific charge also 0. Okay. And symbol for electrons and protons and neutrons. The symbol for electron is -1 is 0. So here -1 represents the charge for electron. 0 represents the mass of electron. So the mass of the electron is very negligible. Hence we represent with 0. If you observe proton +1 P1. Here +1 represents the charge of proton. Here 1 represents the mass of the proton. 1 unit, 1 AMU mass, 1 AMU of mass. And here also same. 0, the neutron is represented the 0 N1. Here 0 represents the charge of the neutron. Neutron charge is 0. And neutron mass is 1. So 1.00 something. Yeah. So these are the symbols for electrons and protons and neutrons. So electrons were discovered by J.J. Thomson, protons were discovered by Goldstein, and neutron were discovered by James Chadwick. And so the electrons are located around the nucleus in the atom. Around the nucleus, the center of the atom is nucleus, and around the nucleus the electrons are revolving. So around the nucleus in the atom the electrons are located. So if you observe the protons are present in the nucleus. The protons are present in the nucleus, and as well as protons, neutrons are also present in the nucleus. This is the brief information about these are the differences between electrons and protons and neutrons.